All right, so hi guys. It is time for me to go through a little bit of review for the quiz. Some of you are taking it tomorrow, and some of you are taking it on Wednesday. All we have to do for the first couple is convert from degrees to radians and radians to degrees. So I'm going to go ahead and show you how to convert from degrees to radians. Obviously, you multiply by pi over 180 degrees. Okay, and go ahead and write this out. 450 degrees over 180 degrees. Don't forget that pi over here. Great. Okay, you can automatically divide by 10, but then 18, is there 18 in there? No, but there's a 9 in here, right? So so you could divide both of these things by 90, even if you didn't know that. 90 times 5 is 450, and 180 divided by 90 is 2. There we go, 5 pi over 2. Right? So it's just simplifying a fraction. Basically, it's not a big deal. This is basically the same down here. I know it looks different, but it's basically the same idea, except instead of multiplying by 180, pi over 180, we're going to multiply by 180 over pi. Now here we divide by 180, multiply by 180 over pi, so we can cancel out our pi's. Our pi's go away, right? Now, do I have to divide 180 by 4 right away? I do that, and I was showing you that in the classroom, but I guess we don't have to, but I want you to write it out like this: 9 times 180 divided by 4. Now, if you didn't know that 180 was divisible by 4, and we're going back into the idea of 45s again, you could divide by 2 and then divide by another 2. But the truth of the matter is that 180 is divisible by 4. So it's 9 times 45 divided by 1. Okay, well, 9 times 4, that's 360. 9 times 5, so that'd be 405. Does that make sense? And we're all done there. So I'm going to move on from here and move to the second part. This is number 3 on the page. It says list all all angles that are coterminal to the following. And then it says give me coterminal angles of 270. Now I'm going to, you're going to make fun of me. Maybe I will just make a circle. Give me a second, I'll make a circle. So let's just talk about a circle. Oh, that's horrible. Let me undo that. And then see if I can make a circle. Does it look like a circle? There we go. That looks like a circle. And it may not be perfect, but, hey, what the heck. Let me get rid of this. And we can get to work. All right. So if I'm looking at a circle, and this is 180, plus 90 is 270, right? So this is a 270 degree angle from here. I want to know what other angles are going to be 270 degrees. And if I go all the way around another 360, I've added 360. I have gone around 270 plus 360. right? And then, the truth be told, if I go the other way, back 360, I've also come back to this coterminal angle. So if I just put an n right next to this, if I add 360 times n, 360 degrees times n, that is all I need to do on the line to tell the teacher, whoever's in charge, that you understand the concept that if you went in the positive direction 360, you'd come back to this 270 degree angles. Yes, it would be what, 630 degrees? But it would still be at that same point on the circle. It would still be right here on the circle. So add 360n. The same thing holds true if you just add a full circle's worth of radians times n to your number in radians, right? And really and truly, that's the same idea here, right? If I make another circle, it's taking me too long. If I make another circle, right, there's my circle. Get rid of it. There we go. And I want to find what? 7 pi over 6. So that's just 30 degrees past 180 there. There's 180 plus 30 degrees. It's basically this angle here. Okay? Sorry, they're not straight lines, but you know, I'm trying to draw on this graphics pad. If I add 2 pi radians to it, I've come all the way back, right? If I subtract 2 pi radians, oh my God, I did them backwards. Anyway, if I subtract 2 pi, if I add 2 pi radians, I've gone here. If I subtract 2 pi radians, no, I did it right. Thought I did it wrong. Then I end up in the same place. So it doesn't matter as long as you start at that coterminal side, or that terminal side, which is the side that actually creates that degree measure, then you're safe. So we're just making sure that we add 2 pi n, or 360 degrees n. Good. Moving on. All right, this is the big one, guys. This is the one that annoys you the most. So I'm going to go ahead and grab a color. Let's go ahead and grab green. All right, so the first thing I have to do, well, besides get ready to draw on this page, is I have to find this. I don't know what my hypotenuse is, right? Okay, well, I use Pythagorean Theorem, a squared plus b squared equals c squared. So it's going to be 6 squared plus 7 squared equals c squared. Great. 36 plus 49 equals c squared. What is that? 85. 85 equals c squared. So the square root of 85 equals c. Okay, so we'll say it's the square root of 85. Remembering that this is the angle in question. So across from it is the opposite. That's down here. So I have 7. So my sign would be 7 over root 85. Well, I cannot have a radical in the denominator. So I'm going to multiply by root 85 over root 85, right? When I do that, what I'm going to end up with is 7 times root 85 over 85. Now, I originally had 7 over root 85, so when I show the reciprocal over here, I do have my root 85 in the numerator and 7 as the denominator. Now, my adjacent side is 6, so I'm going to just write this just as I wrote the other one. 6 times root 85 over 85. Right? I had to do this same idea like I did with the last one to get rid of the square root in the denominator. And like the last time, I'm just going to take the reciprocal of the original, which is 6 over root 85, but show the reciprocal, root 85 over 6. Now the tangent and the cotangent are simple. 7 over 6 and 6 over 7. Cool? That's easy enough. So there'll be 2 like that. And then the last problem is probably the most annoying problem, I guess, for you guys. There it is. Find the rotation in revs a minute. It says revs a minute given omega, which is some sort of speed. So this is omega equals 5 pi over 3 radians a second. So all I'm going to do is a little bit of dimensional analysis. All I want to do is change my units. So I'm going to multiply, because I don't want seconds anymore. I want minutes. So I'm going to say it's 60 seconds, so I can cancel seconds with seconds, over 1 minute. Whew, that's bright. And then I'm going to multiply by, I want to change my radians into revolutions. So I'm going to say that 1 revolution is equivalent to 2 pi radians. Okay? So now I can do a lot of canceling. So where's my cursor? There it is. My radians cancel out with my radians. My seconds cancel out with seconds. I'm left with revolutions and minutes. So I'm going to write that over here. Revs. And I'll give myself some space here. And min. There's one more thing I can cancel, and that's pi cancels out with pi. That's making life so much easier. Now, some of you in class just wanted to go ahead and do the multiplication straight across and then simplify after the fact. That's okay. If you wanted to make it 300 over 6, that's okay, because that's 5 times 60, which is 300. And then 3 times 2 is 6. And that's okay. Do I like it? Nah. Because I would eventually get to my 50 revolutions eventually per minute. Is that the end of the world? No. Heavens no, it's not the end of the world. That's it. If you have any questions, please let me know. Watch it again if you need to see the dimensional analysis piece again, but you should have no problem with the test. Thank you, and I'll see you.